Chapter 1, Section 3 is called Solving Equations with Variables on Both Sides. The learning objective is we are learning to write and solve equations with variables on both sides of the equal sign. So now you're going to see a multi-step equation where you have x's on the left and x's on the right. To solve equations with variables on both sides, you're going to collect the variable terms on one side and the constant terms on the other. And remember, a constant is numbers that stand alone. So -8 and 4, or 3 and 2, -2. Those are constants. But the variable terms are like 3x, -4y, right? They have a coefficient and a variable. So let's look at example number 1. 15 minus 2x equals -7x. Again, some people like to write the line down the equal sign just so you can keep your notes organized and you can remember whatever you do to one side of the line, you have to do to the other side. So I have a constant here. I also have a variable term and then another variable term on the right. So in order to solve this, I'm going to get all my variable terms to one side and my constants on the other. So let's eliminate this minus 2x by doing the inverse, which is add 2x. Because when I eliminate it on this side, I also have to add it to this side. So I'm left with 15 equals, what is negative 7x plus 2x is -5x. Now I'm just at a standard one-step equation. You divide both sides by the coefficient, because that's the inverse, division, and you're left with x equals -3. Let's plug it in to check our solution so that we definitely know if we did it right or not. So we're going to write the original equation, 15 minus 2x equals -7x. And I'm going to substitute in, instead of x, I'm going to plug in my solution, which was -3, and see if it makes a true statement. So 15, we have -2 times -3, or -2 times -3 is +6, equals -7 times -3 is +21. And 15 plus 6 is 21. And 21 equals 21 is true, so we did it correct. Here is our final solution. Now, when we have variables on both sides, we have special cases. We're going to talk more about these special cases in class, but I want to just show you what could happen. So here's my equation. 3 times the quantity of 5x plus 12 equals 15x. Again, I have variables on the left and variables on the right. So first, we're going to eliminate the parentheses by distributing. I'm going to distribute 3 times 5x and 3 times 12. 3 times 5x is 15x, plus 3 times 12 is 36, and that equals 15x. Do you notice anything? Now I'm going to keep doing what I'm supposed to do, and I'm going to get the variables all to one side. So I'm going to take these 15x's out and also do it on the other side. And I'm left with 36 equals, well, 15x minus 15x is 0. My x terms have been eliminated. I have no more x's. Does 36 equal 0? Never. So we write no solution. There is no solution to this equation. You cannot plug in any value for x that will make this equation true. So now what we need to add to our little book of knowledge is sometimes you could have x equals 3, but sometimes you could also write no solution. Let's take a look at another special case. -4 times the quantity of 4y plus 1 equals negative 8y minus 2. So again, you want to draw the line. And let's start by distributing to eliminate these parentheses. Negative 2 times 4y is negative 8y. Negative 2 times a positive 1 is negative 2 equals negative 8y minus 2. Wait a second. Look, they are the same on both sides of the equal sign. Well, let's just keep going just to see what's going to happen. I'm going to add 8y to both sides because I want to get all my variables to one side. But negative 8y plus 8y, my terms have canceled, my y terms have canceled out, and I'm left with negative 2 equals negative 2. The equation negative 2 equals negative 2 is always true. So the equation has infinitely many solutions. When you do a little bit of work to your equation and you see that the left side and the right side, those two expressions are exactly the same, that means you're going to have infinitely many solutions, which ultimately means any number I substitute into this equation for y will make this equation true. You can plug in 0, you could plug in 1, you could plug in negative 100. Any number you plug in for y, it will work. So let's pick 1 because 1 is easy to work with. And we're going to start with our original equation. Negative 8y. Oh, I'm running out of room. And instead of y, I'm going to substitute in my 1. So let me go back to it. Negative 2, 4 times 1 plus 1 equals negative 8. Times 1 minus 2. Just fits. Okay, so inside my parentheses, I have 4 times 1, 4, plus 1 is 5, times negative 2. And then over here, I have negative 8 times 1, which is negative 8, minus 2, which is negative 10. And over here, I have negative 10. Does negative 10 equal negative 10? Yes. Then that means that 1 can be a solution. In this case, plug in any number you want. It will always work. So let's just recap because that was a lot to take in. Now you have 3 options when you solve an equation. Option 1 is you could have x equals a number, which is what you're used to. X equals 5, x equals negative 2. X can even equal 0. And let's throw in a fraction because I know how we feel about fractions. Option 2 is you can solve an equation and you can write no solution. That doesn't mean if you don't understand how to solve it, you just write no solution. So just be careful with that. And option 3 means sometimes you'll solve an equation and anything will work. Infinitely many. Okay. Infinitely many solutions. Or sometimes you just might see the infinity sign. All 3 of these are now options for us in Algebra 1. So try the next few problems on your own.